Hello everyone, in this video I'm going to talk about performance charts for classification. Performance charts are graphical representations that we use to assess the predictive performance of data mining models. The most popular performance charts are cumulative lift chart, the decile-wise lift chart, and the receiver operating characteristics or ROC curve. We start with the cumulative lift chart. A cumulative lift chart, also called cumulative gains chart, shows the improvement that the predictive model provides over a random selection in capturing the target class cases. So here in this example, our target class is when y is equal to 1, and non-target class is when y is equal to 0. So the baseline model or random selection model randomly assigns 1s and 0s to y predicted. And the cumulative lift chart shows the improvement of our predictive model over the baseline model. Here the x-axis represents the number of cases and y-axis indicates the cumulative number of target class cases, which we can call them as case 1, identified by the model. The orange diagonal line represents the baseline model, where observations are randomly selected without using any predictive model. So to find the lift, first we are going to find the percentage of target class cases predicted by our model, and then we will find the percentage of target class cases predicted by the random selection or baseline model. Here in this graph you see that baseline model correctly identifies 190 of 2000 observations as target class 1, which is equal to 0.095. That is the baseline model. And our predictive model, here represented by the blue line, if you go 2000 up to here, 465 cases are correctly identified as target case 1, and that is equal to 0.2325. So the lift is the ratio of percentage of target class cases predicted by our model, 0.2325, divided by percentage of target class cases identified by baseline model, 0.095, which is equal to 2.447. Therefore, our model able to capture 2.447 times as many class 1 observations as compared to the 2000 observations selected randomly. Therefore, the cumulative lift chart shows how well a predictive model can capture the target class cases compared to the random selection. A high lift number is desirable, and the lift curve that is above the baseline is indicative of good predictive performance of the model. Now next we talk about decile-wise lift curve. Decile-wise lift curve conveys similar information as the cumulative lift chart, but presents the information in 10 equal size intervals. It is usually presented as a bar chart where the y-axis represents the ratio of target class cases identified by the model to the identified through random selection. So therefore the y-axis represents the lift and x-axis represents the deciles. Here on the screen you see one decile-wise lift chart. This figure shows that lift for the first 10% of the observations, which is the first bar, is about 7.1, which means that the top 10% of the observations selected by the model contain 7.1 times as many class 1 cases as the 10% of the observations that are randomly selected. Decile-wise lift chart can also be used to determine the point at which the model's prediction become less useful. For example, look, after the second decile, which is the third decile, the lift values are below 1, suggesting that the model will capture fewer target class cases than random selection. That means if our goal is to capture the target class cases, we should focus on the first 20% of the observations that have the highest predicted probabilities of belonging to the target class. And next I'm going to talk about ROC curve. Receiver operating characteristics curve shows the sensitivity and specificity measures across all cutoff values and how accurately the model is able to classify both target and non-target class cases overall. Here you can see one ROC curve on the screen, and the x-axis is the 1 minus specificity or false positive rates. 1 minus specificity ranges from 0 to 1. 0 indicates classifying 100% of the non-target class cases correctly, and 1 indicates 0% of non-target class cases correctly. Y-axis is the sensitivity, which also ranges from 0 to 1. 0 represents that 0% of the target class cases correctly identified, and 1 represents that all target class cases correctly identified. And here again, the diagonal line is the baseline or random classifier. A good predictive model would have a RAG curve that lies above the diagonal line. The greater the area between RAG curve and the baseline, the better the model is. The overall performance of the model can also be assessed using area under the curve or AUC measure. AUC measure ranges from 0, worst possible model, to 1, perfect model. The diagonal line has the AUC of 0.5. The software programs such as Analytics Solver and R will provide the AUC value, but in Excel you cannot calculate the AUC value. This figure has AUC value of 0.9457, which suggests that the model has very high predictive performance. In the following video, I'm going to show one example of how to build ROC and cumulative lift charts using Excel.